Section 2.1 deals with complex numbers. This is dealing with the imaginary unit I. We did this in Algebra 2 Trig, where I equals the square root of -1, and therefore if we square both sides, we get I squared equals -1. So by squaring both sides, we get this. So this is our definition of I, and we'll be using this throughout. So for example, if we have the square root of -25, that would equal the square root of -1 times the square root of 25, which would be I times 5. And if you remember, we always put the I after the whole number. Conversely, if I have 5I squared, distributing, and I can distribute because that's a multiplication sign, not an addition. Remember, you cannot distribute over addition. That's a no-no. But over multiplication, we're fine. So 5, that would be 25 times I squared, which is -1, or -25. Okay? So that's how imaginary numbers work. Now, if you remember, complex numbers are numbers that have a real portion and an imaginary portion. Okay, come on, imaginary. So anything that has a b value equal to 0 in this expression is a real number, and if b does not equal 0, then we have an imaginary number. And we can perform several operations on complex numbers. Again, this should all be reviewed. Let me do a couple quick examples for you. If I have an imaginary complex number and I add it to another complex number, then I'm simply going to add the real portions together and add the imaginary portions together. Same thing can happen with subtraction. I can also work with multiplication. So if I have 4i times 3 minus 2i, I'm going to distribute. I will get 12i minus 8i squared. And anytime we get an I squared, we need to simplify that to -1. So that becomes 12i plus 8. And to put it back into our a plus bi form, we would write 8 plus 12i. We can also multiply two binomials. So 7 minus 3i times -2 plus I. And again, we're going to FOIL it just like we've always done with binomials. So we get -14. Outside is 7i. Inside is 6i. And my last is -3i squared. So -14 plus 13i, and remember that I squared is going to change the sign, so that will be a +3. Grouping everything together, I get -11 plus 13i. So those operations should be familiar to you. This should all be stuff that you have seen before. Complex conjugates. Remember, conjugate binomials are the form a plus b times a minus b. And when I multiply any conjugates, I get a squared, the outside inside cancel, minus b squared. The same thing happens with complex conjugates. And if I multiply two complex conjugates together, I'm going to get a real number. So for example, and let's do it with our generic first, a plus bi times a minus bi will give me a squared plus abi minus abi minus b squared I squared. Anything with the I is going to cancel, and this last term, since it has an I squared now, can be turned into a real number. So let's do one with some actual values. The complex conjugates 3 plus 2i and 3 minus 2i gives me 9 minus 6i plus 6i. I don't really even have to do that part. And then minus 4i squared. That becomes 9 plus 4 because minus 4 times negative 1. So the answer is 13. I'm going to use this particular tool when I do division. If I multiply the denominator by the complex conjugate, so if I have 7 plus 4i divided by 2 minus 5i, to do the division, I'm actually going to do a simplification. So multiply the top and bottom by the conjugate. On the bottom, I will get 4 minus 25i squared, which will become 4 plus 25. The top I FOIL just like normal. 14 outside and inside is 35i plus 8i. That's 43i. And then 20i squared. Again, this becomes negative 20. So I get negative 6 plus 43i. And that is the answer to this original division problem. Now I do want to put this back into the standard form for a complex value, so I'm going to write it as negative 6 29ths plus 43 29ths I. And that's how we do division. Okay? A lot of this is review. We're just kind of going through this quickly. It's just generic stuff. Roots of negative numbers. If I have 4i squared, I will get 16i squared, or negative 16. If I have negative 4i squared, I will also get negative 16. So therefore, the square root of negative 16 really can be plus or minus 4i. For our purposes, we are going to deal with the principal square root as being the positive. So unless it specifically gives you a plus or a minus in front of the radical, we are simply looking for the principal square root. So back to my previous example, the square root of negative 16, and again I'll show the breakdown just really quickly here. That's I times 4. We're just going to say that 4i is the square root. We're going to choose the principal square root, or the positive value, when we take the square root of any negative number. Unless it's otherwise specified by a minus sign in front here, then we would of course put a minus in front of that. Okay, so just kind of a watch out for that. So square root of negative 36 would be simply 6i. We don't have to worry about the plus or minus. All right, operations. If I am going to do any operation when we have the square root of a negative number, we must first express all square roots in terms of I. This is really, really important. So before you do any operations on radicals with a negative underneath, first change it to an I, change it to an imaginary number before you do the operations. So let me give you an example. If I have the square root of negative 18 minus the square root of negative 8. First I'm going to change this into I values. This is I root 18, and I can simplify this root 18. Remember doing this, root 9 times root 2, so that's 3 root 2. So this is going to be 3i root 2. This is going to become I root 8. Root 8 is 2 root 2. So now I have a common term. I can only add and subtract when this is a common. 3 minus 2 is 1. My answer is I root 2. Let's look at another example of an operation on a negative radical. Let's say I'm starting with negative 1 plus the square root of negative 5 squared. Before I distribute that squared, before I FOIL this out, before I FOIL it, I want to change this value. So I'm going to say negative 1 plus I root 5. Then I can do my FOIL. Negative 1 plus I root 5 times negative 1 plus I root 5. First gives me 1. Outside and inside are both negative I root 5, negative I root 5, and then plus I squared times 5. So I've got 1 minus 2I root 5, and remember that's a negative 1, so minus 5, final answer, negative 4 minus 2I root 5. Okay, so those are some of the things that we have to do prior to doing an operation. Change any radical with a negative sign into an I expression. The last thing we want to look at is quadratic expressions with imaginary solutions. So if I have 3x squared minus 2x plus 4 equals 0, and I realize that I can't factor it, so I'm going to use my quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This gives me 2 plus or minus the square root, that's going to be 4 minus 48, that's negative 44 over 6. Now, in the past we would have said that there are no solutions to this. Well, there are no real solutions to this, but there are some imaginary solutions. So let's simplify. This would be I root 44. That would be 2I root 11. And then again, simplifying this into our actual form, you will see that we end up with 1/3 plus or minus I root 11 over 3. And that's my final solution. And that's it for our quick review of imaginary or complex numbers. And we will move on to the next section.